the specific latent heat of fusion of ice is that, and specific heat capacity of water is that. Heat supplied at a constant rate to a block of ice of mass that. So what you've got here, I'll draw it for you. You've got a block of ice. And its mass is 0.08 kilograms. And it's initially at 0 degrees, and we'd like to increase its temperature to 20 degrees. How much energy do we need? So what happens first when I start adding energy to this ice? What's the first thing that happens?
Melting.
Yeah, so first it needs to go from a solid to a liquid and then increase its temperature. So, Abdal, for example, what's the name when you change energy, different forms? When it changes shape, when it changes form, what's the name? Yep. Yep, latent, good man. So, latent heat first, and Andy, what's the formula for latent heat?
ML.
ML. Then it increases its temperature. So what's the energy formula for that one? You know it? MC delta T. So let's put in the information. M 0.08. The L here is given as 320 kilo. Plus M C delta T. Alright, so let's see what we get for that.
Do we have that?
Yeah, it's given in the question. So I got, now that seems too small. Let me check it again. 0.08 times 320 times 10 to the power 3 plus 0.08 times 4200 times 20. Yeah, okay, that's it. Oh, well, it's only a tiny bit of ice actually. 32320 joules.
So what's the last bracket?
20. Okay. Part B is draw the graph where on the y-axis is the temperature and the x-axis is the time. Okay, so what's the temperature at the beginning? 0. And then what happens to the graph as time goes on?
Increasing the temperature. Oh no,
No.
stays at constant.
Stays constant as it's melting, and then once it's all become a liquid, then it can start to increase. So the graph looks like that. So if you want to label your point on it to make sure you get full marks, that point there is called the fusion part, or the melting part, I suppose.
Can the ground like the straight line because it is 0 is on a 0 is harder to see. Can I move out like the
Use Kelvins?
maybe use Kelvin?
Yeah, that's fine, yeah.
But if I draw the 0,
Just do a different color like I did.
is 0.
Yes, it is. I'm sorry to tell you. Use Kelvins or just use a different color. Okay. Now, part C. If this process is 40% efficient, how much energy do you need? So now efficiency is 40%. So we can say 40% equals energy out over energy in, multiply 100. So which do we know, the output or the input energy? This number earlier, is that the out or the in? No, it's the out. The out is what you get done, and the in is what you have to give it. The output is what's done, the input is what you put in. So anyways, yeah.
The next time, can we answer like that without any more steps? Like just
Like that's fine. Yeah, that's fine because it's just a simple swap then. Yeah. Okay. 6 now, and I think we'll finish with 6 then.